Okay, so now that we have gone over using slopes and basic graphing skills, I want to introduce to you the slope-intercept formula. And the slope-intercept formula is this formula right here. It's y equals mx plus b. And the mx means m times x. That's why they're right next to each other. So m times x. And don't be alarmed about this formula. I know it looks like a big deal, but it's really just representative of everything that we've already gone over in graphing, just put into an algebraic equation. So first, let's look at the m here in y equals mx plus b. The m, as you recall, just stands for the slope. And the slope is the rise over the run. So you find a point, you pick a point on the line, and then you count up, and then you count over. And that's what the slope is. The slope is just how steep the line is. And then B is what I introduced to you in the last video. That's the Y-intercept. And the Y-intercept is just a fancy way of saying where the line crosses the y-axis. And remember, the y-axis is this pink up and down axis. This pink up and down axis. So here's the y, this pink line going up and down. That's the y-axis. And wherever the line crosses this y-axis, that's what B is. That's the y-intercept. And then we have the y over here, and that's just going to be that y value, x comma y, for your point when you go to make a point on the graph. And then this x is just the x number, the x value in your xy coordinates. So I'll write down at the bottom just the reminders for you. The m equals the slope, and the b equals the y-intercept. So we're going to go take a look at this line, and we're going to we're going to plug in the numbers and write out this algebraic equation using this line to the left. So first, let's look at the xy values for the point. As you can see, the point is this blue dot on the line, and that's our one point, because remember, we only need one coordinate to make a line if we have the slope, or if we have the b value, the y-intercept value. We can use that as our second point if we want to. So let's look at this blue dot, our point, and on the x value is going to be negative because it's to the left of the 0. So we're going to count backwards from the 0. 1, 2, 3, 4. So our x value is going to be -4. And our y value is going to be negative also because it's below the 0, and it's only one notch below the 0. So our y value is going to be -1. And then let's look at the slope. Let's find from this point, let's find the next place the line crosses an intersection of an x and a y. So the next point that this line crosses and where an x and a y intersects is going to be this notch right here, because everything before that, the line's not really crossing any intersections. So we're going to go from the blue dot to the green dot. So we're going to get the rise first, which is 1 notch, because it takes 1 to get up to the line where the green dot is. And then we're going to count over 1, 2, and that's going to be your run. So for your slope, your rise is going to be 1, and your run is going to be 2. Now let's look at the B value, the Y-intercept value, where the line crosses the Y-axis. So can you see where the line crosses the Y-axis at this first notch right here? So that's going to be a positive 1. So we're going to say for the B value is going to be 1. So if we write this all out, a negative 1 is going to equal 1 over 2 times negative 4 plus 1. That's going to be your slope-intercept formula. So let's work this out just to make sure that we did this right, that this formula is correct. So first we're going to take this 1/2 times negative 4. So 1/2 times negative 4 is going to be a negative 4 over 2, which is equal to a negative 2. So now we have a negative 2 plus 1, and that's the B value. So negative 2 plus 1 is what? Negative 2 plus 1 is going to equal negative 1. So this checks out. So negative 2 plus 1 equals negative 1, and negative 1 equals negative 1. So this is correct. So we have plugged in the correct numbers for this slope-intercept formula. So now we're going to use this formula to find the slope. Instead of looking at the graph and counting how many boxes up and over it is for the slope, we're going to use this algebraic formula to find out what the slope is. So your slope-intercept formula is y equals mx plus b. So your y value is going to be the y value in your xy coordinate, and that's the blue dot on the graph. So your y value is going to be positive 4. So we're going to write down here positive 4 equals, and m is what we want to find for the slope. So we don't know what m is yet. So m, and then times x. So x is going to be your x coordinate for the blue dot up on the graph. So that's going to be negative 2. So that's going to be m times negative 2. And then plus b. And b is the y-intercept. And the y-intercept is where the line crosses the y-axis. So as you can see down here, the line crosses the y-axis right here at negative 2. So we're going to write minus 2, which is the same thing as writing plus negative 2, in case that's confusing. Since it says plus b up here in the formula, we're saying plus b plus negative 2, but that's just the same thing as saying minus 2. So we're just going to write minus 2 here. Okay, so to solve this, we have to get the m all by itself on one side of the equal sign, and all the numbers put together on the other side of the equal sign. So we need to start with this minus 2 first. In order to get this 2 on the other side of the equal sign, away from the m, we need to take both sides by plus 2. So that gives us 6 equals m times negative 2. and these cancel each other out. So now we have 6 equals m times negative 2. So if we want to get rid of this negative 2 times the m, we need to divide both sides by negative 2. So this negative 2 and that negative 2 cancels each other out. So now we have 6 over negative 2 equals m. So that's the slope. And of course we can reduce down this 6 over negative 2 into 3 over negative 1 equals m. It's the same thing. Or you can just write m equals negative 3 over 1. The negative sign doesn't have to be attached to the 1. You can just write negative and then 3 over 1. And of course this can finally be reduced down to just plain old negative 3, which is the same thing as negative 3 over 1. So that's the slope. Now let's look over on our graph and check our work and see if we got the slope right. Now if you remember, we're going to find our blue dot, our original dot, our xy value up here. And then the next time this line crosses an intersection of an xy value is going to be right here. That's the next time the line actually crosses an intersection where these xy values intersect. And we're going to count from the blue dot to the second dot, and we're going to count over 1, and then we're going to count down 1, 2, 3. So that is your rise is going to be the negative 3, and your run is going to be the over 1. So, and remember from the previous video about the slopes, if you have a negative 3 over 1, it doesn't matter which number the negative is attached to, because we could have very well gone the other way and counted up 1, 2, 3, and then backwards over 1 if we had room on this graph, on the paper, and that would be positive 3, negative 1, but it still would have given the slope for the line. It still would have given us another point on the line to show how steep the line is. So it doesn't matter which number has the negative if you have a negative slope. So it looks like we did a good job. We got negative 3 over 1, and that's what we got for the slope when we solved it algebraically using the y equals mx plus b, the slope-intercept formula. Okay, so let's do something else with the slope-intercept formula. This is how you might see it on a test. You might see it written like this, just using y and x as variables, but then they actually put the slope in, the number for the slope in, and they put the number for the y-intercept in. So we have y equals 1/3 x plus 2. And we need to find out what the x and the y are. So we're going to graph this and find out where the x and the y could be. So and this is one way of doing it if we graph it. So let's take the y-intercept value, which is 2, and remember that's just where the line crosses the y-axis. So we're going to go to the y-axis and we're going to put a dot at 2. And then we're going to look at the slope, and the slope is 1 over 3. So that's up 1 over 3. 1, 2, 3. So there's a second dot. And so now we can graph this. It's up 1 over 3. And if we want to take this line out further, and if you don't have a ruler, we can just count the slope again. Up 1 over 3. 1, 2, 3. Put another dot. And then up 1 over 3. 1, 2, 3. Put another dot. And then on the other side here, we can go down 1, backwards 3. So down 1, 1, 2, 3. And then down 1, backwards 1, 2, 3. So there is our straight line. And so our XY values can be really any one of these points along the way, along the line. So our XY value could be negative 1, 2, 3, 4, 5, 6, negative 6, comma, 0. Or our XY value could be negative 3, comma, 1. Or our XY value could be 0, comma, 2. Or our XY value could be 3, comma, 3. Or it could be 6, comma, 4, and so on. So the XY values could be any one of these. It doesn't matter. They're still points on the straight line. So these are all acceptable. Now another way to solve this problem is if we plug in a 0 for the y and then find out what the x is. And then we would have 0 as a y coordinate, and we would have the x-intercept, which is where the line crosses the x. Just like with B, with the y-intercept is where the line crosses the y-axis. If we plug in 0 for the y, then that's going to give us the x-intercept, where the line crosses the x-axis. So let's do that. Let's plug in 0 for the y, and let's just algebraically solve this problem. So we have 0 equals 1/3 x plus 2. Well, first we have to get rid of this 2 by subtracting it from each side. So this plus 2 and minus 2 cancel each other out. So now we have negative 2 equals 1/3 x. So now we have to get rid of this 1/3, and we can do that by multiplying it by 3 over 1 by both sides. So this 1/3 and this 3 over 1 cancel each other out. So now we have 3 over 1 times negative 2 equals x. And 3 over 1 times negative 2, well, we know that 3 over 1 is the same thing as saying 3. So let's just say 3. So 3 times negative 2 equals x. So that means x is negative 6 at the x-intercept. When y is 0, x is negative 6. So let's plot that on the graph. When y is 0, x is negative 6. So that means on the purple line on the x-axis, we're going to go to negative 6, and we're going to plot this x value. That's negative 6. So when y is 0, we're not going to go up or down. We're just going to go to the left negative 6 notches. And then we have, if you go back to the original equation, we have our b value, our y-intercept, which is a positive 2. So when x is 0, y is positive 2. So that's where the line crosses the y-axis at positive 2. If we draw a line from these two dots, we should end up getting the slope of 1 over 3. So let's look. So we'll start at this beginning dot and we go up 1 and over 3. 1, 2, 3. And then if we do that again, if we go up 1 and we can go over 1, 2, 3. So that slope is right. My line is kind of crooked, so it's a little bit off, but so the slope is right, up 1 over 3. So that means we have an x-intercept value of -6 when y is 0, where the line crosses the x-axis, and when x is 0, when the line crosses the y-axis, our y-intercept, our b, is 2. And then x-intercept is -6. So the point of this is that if you have one of these problems, this y equals like 1/3 x plus 2, and you need to solve it, all you have to do is just plug in 0 for the y, and then solve the problem, solve the formula algebraically, and you'll get an x-intercept point. And then you can graph the line. Now, one more way you can solve this problem, you don't have to plug in a 0 for the y and solve for an x-intercept. You can plug in any number you want. You can plug in any number for the y and get what the x is on that line. So if we plugged in 1 for the y, 1 equals 1/3 x plus 2. Well, we'd have to subtract the 2 from both sides. So that gives us -1 equals 1/3 x. And then we have to multiply by 3 by both sides. So that gives us -3 equals x. So when y is 1, x is -3. When y is 1, x is -3. So your xy value is -3, 1. Now let's go back and do it again. Now let's plug in 2 for the y. 2 equals 1/3x plus 2. Well, first we have to subtract both sides by 2. So this +2 and -2 cancels each other out. And 2 minus 2 equals 0. So now we have 0 equals 1/3 x. So if we want to get rid of that 1/3, we multiply by 3 on both sides. 3 times 0 is 0. So we get 0 equals x. So when y is 2, x is 0. So we're going to write that down. Here's x is 0, 2. Now let's do it again. Let's make y 3 this time. So y is 3 equals 1/3 x plus 2. So first we have to get rid of this 2 by subtracting 2 from both sides. So +2 minus 2 cancels each other out. And over here we have 3 minus 2 equals 1. So 1 equals 1/3 x. Now we need to get rid of this 1/3, so we multiply it by 3 on both sides. So the 1/3 and the 3 cancels each other out. And over here 3 times 1 equals 3. So 3 equals x. So when we plug in 3 for the y, then x is 3 as well. So let's write that down. 3, 3. Now let's do this one more time so we get 4 sets of coordinates here. Let's make y 4 this time. Y is 4. equals 1/3 x plus 2. Alright, so first we need to get rid of this 2 by subtracting it from both sides. So that gives us 4 minus 2 is 2 equals 1/3 x. So now we need to get rid of this 1/3, and we can do that by multiplying by 3 on both sides. So this cancels each other out, and we have 3 times 2 equals 6 equals x. So when y is 4, then x is 6. So let's write that down. X is 6, comma, 4. Alright, so you see you can plug in any number into the y as long as you have the slope and the y-intercept, as long as you have the m and the b, and you can plug in any number into the y and get what the x is at that point when the y is that number. So let's graph these coordinates really quick and see what we got. So first we have -3 is our x value and +1 is our y value. And then we have a 0 is our x value and +2 is our y value. Then we have a +3 is our x value and +3 is our y value. And then we have a +6 as our x value and 4 is our y value. So there is our line. And it just keeps going and going and going. And that's the same line that we had graphed previously when we had set the y to 0 when we solved it the other way. So those are some different ways of using this slope-intercept formula. And you are definitely going to see this on a test, so make sure you just memorize y equals mx plus b. The m is the slope and the b is the y-intercept. And this y and x are just the xy values in a coordinate, in a dot on the graph.